The difference of two squares, commonly referred to as dots, is where we have a squared term must be subtract another squared term. The generic example is a squared minus b squared will always factorise into double brackets of the form a plus b multiplied by in brackets a minus b. For part A, we're asked to factorise x squared minus 4. We know it satisfies the difference of two squares as we start with a squared term in terms of x, subtract another squared term. Remember 4 is a square number, it's the same as 2 squared. Hence, factorising into double brackets, we're going to have x plus 2 multiplied by x minus 2. For part B, this time we're asked to factorise y squared minus 121. Again, it satisfies the difference of two squares as we start with a squared term in terms of y, subtract another squared term. Remember 121 is 11 squared. Therefore, factorising into double brackets, we're going to have y plus 11 multiplied by y minus 11. For part C, this time we're asked to factorise 1, subtract m squared. Again, it satisfies the difference of two squares as we start with a squared term because 1 is the same as 1 squared. Subtract another squared term, this time in terms of m. So it's going to factorise into double brackets of the form 1 plus m and in brackets 1 minus m. For part D, we've asked to factorise 25x squared minus 49. Again, it satisfies our condition of a squared term subtract a squared term because remember 25x squared is the same as having 5x all squared. Subtract another squared term because we know 49 is the same as 7 squared. Therefore, factorising into double brackets, we're going to have 5x plus 7 multiplied by 5x minus 7. For question E, again it satisfies the condition of difference of two squares, as we have a squared term subtract a squared term. 4p squared is the same as having 2p in brackets all squared. Subtract another squared term because 9q squared is the same as having 3q in brackets all squared. Therefore, factorising into double brackets, we're going to have 2p plus 3q multiplied by 2p minus 3q.